Alright, so we are going to do the implicit rule. Implicit rule is not something new or something strange. It's exactly what you have been doing now. So let's go put that thing there and you'll see it is exactly what you have been doing. So let's start with the first one. Let's start with that one there. Alright, check now. Be careful. Now, you see, you're going to derive that x squared. You derive the y squared. You derive the one with respect to x. So when you derive this one, think about it. It becomes 2x. But you should be saying times. Remember the derivative of the base. dy all over d. dx, I'm sorry. I'm thinking something. dx all over dx. You should be putting that pink part, correct? But we know it's 1, so we kinda leave it because it's gonna cancel. Even though you put it, is fine. Then we say plus. Watch here. You do the same thing. Pretend that was x here, this y. Derive it the normal way. So it's gonna be 2y. Now times the derivative of the base, that is dy all over dx. It's because with the implicit implicit equations you can't solve for y direct. So that's what we got now. And then everything must be equated to, now derive the derivative of a constant, it's 0. Do you see now? Do you understand everything I just did? Yeah, all we need to do is to make what's in the purple box. You just solve for dy over dx. Like when they say solve for x, solve for the pink box. Everything needs to go to the left. That's all. That's all you have to do. So if I were to write it step by step, I've got 2y multiplying the dy, because you must end up with dy over dx. That's what you need to solve for. Equals to, that 2x goes to the other side. You transpose it. It's actually 2x. To end up with dy over dx, you must divide by 2y. So that means next step you're going to have dy all over the dx equals 2. Alright, then you have minus 2y is going to be, 2x rather. 2x and then all over 2y. Alright, you can see, you can simplify that. You now have minus x all over the y. Now, you're not done. You are not allowed to have y this side and a dy. The y must disappear. How do we do that? Well, simple. You go back to this equation here. Just make y the subject. When you make y the subject, you basically have y squared equals to 1 minus the x squared. And if you remove the square root, the power of that, you're going to have the square root of that. So that means you just have to replace it by that. So you now have minus the x and then all over that y. That's how it's gonna be. Now maybe at the moment you might say to me, why didn't you just let me solve for y like that? Because that is the same as 1 minus x squared to the power of half. Then I can use the power rule. No problem. You could have done that. But why didn't I let you do that? It's because if I let you do that, solving for y, when I know it's implicit, you're going to come across the questions where it is practically impossible to solve for y. And you are so used to solving for y. Now you're like, oh my gosh, this one I can't solve for y, therefore I can't do it. So I'm trying to tell you, without solving for y, you are able to deal with everything. Are we together? Yeah, that's the